Okay, this is a little sheet, and what it does, I'm going to draw a line right here on the sheet. Over here you have metals, and metals tend to form cations. That's positive ions. They lose electrons. That is to say that metals tend to oxidize. So Leo the line goes Gur. LEO, loss of electrons, is oxidation. Okay, the electrons are losing are valence electrons. So if you look on the right side is the original size of the atom. This is the atom. On the left side, this is the ion. And so the biggest thing we can take to this is that cations become much smaller than their. This is why I usually do these videos after 12 o'clock at night. I'm doing this one early. Much smaller than their neutral atom. Okay, so if you just look at this, the atoms become smaller because they're losing their outer electrons. So if I looked at aluminum, it's neon as an inner core right there with 3s2 and 3p1. These are the electrons we're losing, the outer shell, okay, and becoming much smaller. Nonmetals. Nonmetals tend, and one thing I say about metals, they have a low ionization energy. They become positives easy. Nonmetals have a high electron affinity. And if you have an affinity for something, that means you like it. If you have an electron affinity, that means you gain electrons. Okay? They gain electrons because they're very small and they have open shells. They have places to put those electrons in their valence shell. Okay? Nonmetals are the Gur. They gain electrons, they tend to reduce, so they become negative anions, and they gain electrons. And that's nonmetals. Okay, and in general, anions become larger than the neutral atom. So on the right side you have the atoms. This would be sulfur. On the right side you have the anions. And as they gain, it's actually due to more electron repulsion. So as you're gaining electrons, the electrons are repelling. They have the same number of protons holding them, so they become larger. And it's about metals and nonmetals. Okay, almost done. When you go into the review packet, the questions are very easy. If I was to ask you, nitrogen, phosphorus, arsenic, the question would be which one's the largest? Well, it would be arsenic at the bottom. Which one has the greater electronegativity? Nitrogen at the top. By the way, you might know that usually it's going to be the extreme, top or bottom. Now, I'm not going to go on the test. I won't hold you to any of the, there are a few exceptions due to half-filled shells. Ionization energy, nitrogen's higher, arsenic's lower. Affinity, nitrogen's higher, arsenic's lower. And then finally you got, the last one would be electronegativity. Nitrogen's higher because it has a higher Z effective. Well, they all have the same Z effective, just because it's smaller. Arsenic's larger, so it's less. Okay, and then I'll ask you left and right. So anywhere on here I can give you elements left and right and up and down. I will not ask you questions where it's in this direction because it goes against. You know, it's kind of degenerate. The trends counteract each other. I'll usually ask you in this direction. That is, up and over is always smaller, down and over is always larger. So to compare in this direction, it's a lot better. So all your trends tend to be extreme from the top to the bottom. And that's why we have the Zinel line being sideways like that. It's an effect. The sideways Zinel line it divides up cations, metals, with anions, and it's sideways like that because it's the effect of both the effective going up as you go to the right and size as you go down getting bigger, and that's why it's like a sideways line. Now just an example, if I asked you on this level lithium, carbon, and fluorine, and I say who's more electronegative, fluorine, higher Z effective, and it's smaller and it has a higher Z effective. It's smaller because it has a higher Z effective. Okay, which one has the highest electronegativity? We said fluorine. Smallest size, fluorine. Greatest ionization energy, fluorine. Which one has the lowest ionization energy? Lithium. Which one has the lowest electronegativity? Lithium. And then sometimes I might give you columns where it's like this. Okay, and if I said who's got the lowest electronegativity, you would go left and down. Who's got the highest electronegativity? Up and to the right. So I could ask you these, and now I'll just do that and I'll show you the answers when I give you the review packet, but that's about it on periodic trends. I'm going to show you how to do a worksheet, and I think then we're ready to take the review. Make sure you've read the chapter. Probably want to go through your PowerPoint always, and I've posted up videos already that aren't from me, but I'll give you one more video from me and I'm going to show you how to do a worksheet.